Also joined. Let's start. Yes, Madhya. So yesterday we have done till question number 7, and today we are going to start from number 8. Okay, let me draw the figure. So like yesterday, whatever will be very simple, I'll be leaving those for you. And if any question is quite tricky, so we will be discussing about that in detail. Okay, so number 8, let me draw the figure. Here the figure is like this. So this is somehow the figure looks like, and this is the track. Okay, here these are the track. Like you can understand, it's a track where the question says the figure represent a racing track. So it's a racing track. Here only the people can just here only people can run. Okay, can do competition or whatever is going on, it's going on over here only. Okay, nothing in the middle. Now whose left and right end are semicircular. As we can see, this portion looks like a semicircle, and also this portion looks like a semicircle, and the distance between two inner parallel line segment is 60 meter. So the distance between this one and this one, it's 60 meter inner parallel line. So basically this one is a parallel line. If you will look at the figure in your book, it is a straight. Okay, and then a semicircular shape is over there. So these two are parallel with each other. However, in my figure it looks like curve way, but that's not curve. The blue line, both the blue lines are parallel with each other. Okay, and they are 106 meter long. So this parallel line, the straight portion, the length of this straight portion is 106 meter. That is the its length of a straight portion. So these parallel lines are 60 meter apart from each other, and it's 106 meter long. Okay. Now, if the track is 10 meter wide, now the track is 10 meter wide, that means this green part, this one is 10 meter. Here it's 10 meter. Here it's 10 meter. Okay. Here it's 10 meter. The path, the racing track, that is 10 meter wide. Find the distance around the track along the inner edge. Let me write whatever is asked in the question. So it says find the distance around the track. Along its inner edge. That's it. So this is part 1. We have to find the distance around the track along its inner edge. Suppose you started running on this track and you have just taken one complete revolution. So you must be thinking what exactly is the distance you have covered, right? That distance only we have to find over here for part 1. We will be doing part 2 after doing part 1. So if we have to find the total distance, only the distance, okay, if you will take a one complete revolution, then what exactly is the total distance you have covered? That means perimeter of the shape, right? perimeter of the shape, if we are just moving along the boundary of any circular path, that means circumference of the path. Now if we are moving along just along the boundary of any square, that means we are covering the perimeter of the square. Similarly, if you will walking along the boundary of a rectangular path, so that means you are covering the perimeter of the rectangular part. If you will cover one complete revolution, that one like total perimeter you have covered. If you are covering 2 times 3 times, then 3 into perimeter, right? Are you getting it?
Yes, ma'am.
So here we have to find the perimeter of this total path. But how we will find the perimeter? So for finding the perimeter, can you when the perimeter concept was not introduced to you, very like in lower classes, have you done this type of question where this type of shape used to be there? Like a building kind of a structure, a building block kind of a structure. This is 3 centimeter, this is 2 centimeter, this is again 3, this is 1, this is 5, this is let's say 1.5, this is 2, here we are having 4, here we are having let's say 2, here we are having 1, here we are having 4. So we have to find the perimeter of this shape. We have to find the total distance. So this type of perimeter like structure, have you done like how to find the perimeter? In very lower classes, what we used to do, we used to take each and every measurement, like 2, this 2, then plus 3, plus 1, plus 5, plus 1.5, plus 2, plus 4, plus 2, plus 1, plus 4, and plus 3. That's how we used to get the total one complete revolution of this random shape, right? Without even knowing this random shape is a combination of rectangle, square, or what. Okay. Have you done this type of question? Yes, both of you? Not sure. So this is very lower level concept where the student even don't know what is perimeter. Student even don't know what is a square. Like they know the shape like a square, rectangle, triangle. They know the shape, but they don't know what is the formula for perimeter of the square or perimeter of the rectangle. What is the formula for area of the rectangle and square? This much knowledge they don't have. What they start doing, they just start doing, just taking, like we have to find the total distance of the boundary. So what they do, they just take each and every number and then they add it, and that's how they land up at the perimeter of this random shape. Okay. So here also we are supposed to apply similar kind of concept. So when we are talking about the perimeter of the shape, we can say that, let me take different color, let's say orange. Okay, red already I have taken. Let me take a wider one. This one I am taking. Okay. For covering the perimeter, we will be covering this path. Okay, which is 106 meter. Then we will be covering this semicircular path. Okay, that we don't know. Again, we will be covering this path. Again, that is 106 meter. And after that, again, we will be covering the semicircular path that we still don't know. And that's how we will cover one complete revolution, and that will be the total distance, right? If you will start running from, like if you will take one complete revolution, that will give the total distance you have covered, right? Yes or no? Yeah, are you getting it?
Yes, ma'am.
Okay.
Yes, ma'am.
So here we will be having like 106 at the bottom, 106 at the top, that is okay. But what about this semicircular, like this path? How we will find the total distance of that path? So total distance of that part we can find easily by taking the semicircle in consideration. I am talking about this semicircle, this much. If you will cut it out, here I am drawing the semicircle. If you will cut it out, Do we know the radius of this semicircle? We know this much distance is 60. That one is 10 meter, here 10 meter, and there 10 meter. So total diameter we can take it out. That is 60 plus 10 plus 10. That is 70, 80. Now diameter is 80 of this semicircle. Then radius must be 80 over 2. That is 40. 40 meter, right? Now we can find the circumference of this semicircle, right? When we find the circumference of the semicircle, what we get? Only the curve path we get, right? So for finding the curve path, we can find the circumference of the semicircle. That is, what is the formula for circumference of the semicircle? So 2 pi r is the formula for circle, and for semicircle it must be by 2, right? Yes or no? Similarly, for this semicircle, we will be doing the same thing, and the measurement is also the same, just like the left hand side semicircle. So here also we will be having 2 pi r over 2, and that will give the total distance, right? So what is r? R we have already found, that is 40. So we can take r as a 40. This became pi r. So pi we can take it as a 22 over 7. Then this one we can take 40. Here also we can take 22 over 7, and here we can take 40. Here 106 plus 106, and that will give the total distance around the track along its inner edge. Got it? How we will find? Any confusion over here? Jasleen and Madiha?
No, ma'am. No, ma'am.
Okay. Let me check what is the second part. So the second part is asking, just a moment. Distance around the track along the inner edge. That was the first part. And the second part says we have to find the area of the track. Okay, here one thing we have not noticed, that is it says find the distance around the track along its inner edge. Okay, so we missed this inner edge and we have taken the outer edge. What will be the inner edge when we are having this figure? And this figure we are having the same. The question is asking about the inner edge distance, not the outer edge. There is a difference between inner and outer. We are supposed to find this distance, like this one, this semicircle, then this one, then this semicircle. So we have taken this as a 106 and this as a 106. Both are correct, but this inner circle circumference will be different from outer circle. We have taken total as a diameter, right? But when we are talking about the inner circle, inner semicircle, it will be only this much, right? And this much. Can you see it? Here it's mentioned that we have to find its inner edge. Find the distance around the track along its inner edge, not the outer edge. We have taken the outer edge, right?
Yes.
Yes. So that time we have taken the total as a diameter, like 60, then 10, then 10. Total we have taken as a diameter. That will not be the case. Here we have to think about this smaller semicircle, and that distance is already given as 60 meter. So radius will be, directly we can say, if diameter is 60, radius will be 30. So rather than taking radius as a 40, we must take radius as a 30. Now we are done. Everything will be same, but we have to take the consideration of inner circle. Is it clear to both of you?
Yes, ma'am.
Yes.
Okay. Now in this question only, if in your exam outer circle will come, then you are supposed to do whatever we have done earlier. Okay. Now let's move to the next part. Part 2 says find the area of, let me read it properly. It says the area of the track. The area of the track. Now we have to focus on the area of the track. What we have to find for finding the area of the track? Here you can see we are having, when we will focus on the track, we are having rectangular path over here. Can you see? It's a rectangle. The
Yes,
above
ma'am.
one is also a rectangle.
Yes, ma'am.
And this is a ring kind of a structure. Okay, circular ring, which we find the area by subtracting bigger circle area minus a smaller circle area. This is ring kind of a structure. Let me draw it separately. So this is like, we are having a bigger circle like this one, and then we are having a smaller circle like this, and we are only supposed to find this much area. So when we are having such a structure, if we will draw it straight, a bigger semicircle, a smaller semicircle. Here for the bigger one, it is 60 plus 10 plus 10, 80 is the diameter is 80. And for the smaller semicircle, diameter is 60. We are only supposed to find the area of this portion. Can anybody tell me how to find area of this portion only? The ring one. Let's say we are removing this part also. Okay, it is not possible. Okay, so how to find the area of this ring kind of a structure? Anyone? Yes, Madiha?
No, I don't.
Yeah. Are you saying anything? Not sure?
And we should take the area, but we should take the diameter of 60 divided by 2. We will get the radius.
Diameter 61 we should take. When we are focusing on only the track, only the like ring kind of a structure, when we are focusing on that, then if we will take only the diameter 60, that will work. Area of the track. Okay, the track is just like a ring kind of track is there.
The 80.
Yeah. Yes, Jaslyn, any idea?
Ma'am, I don't know.
Okay, so here this is the track. If I'll just set the track, if I will just shade the track, this is the track. This one. The green supposed to find the area of this green one only, the total, not the middle part. So I am trying to say that this green part is the combination of, let me break the figure. I am trying to say that it's the combination of rectangle over here, then a semicircular ring, then again a rectangle, and then again a semicircular ring. Are you able to understand? So we can easily find rectangles area.
Yes, ma'am.
Here also we can easily find rectangles area. We just need length and breadth. So here width is given as 10 meter and length is already given as 106 meter. We know length and breadth both we know, right? Of both the rectangle.
Yes.
Now our concern is only to get this circular, semicircular ring area. So if I will take the total circle area and from that I will subtract the smaller circle, I will just take it out, this is smaller circle, we will be left with this ring, right?
Yes, ma'am.
Right? So total circle diameter was, this is 60, this is 10, this is 10. So total circle diameter was 80. From there we will get total circle radius is 40. Okay, so total circle area will be pi r square by, that is not a circle, that is a semicircle. So total semicircle area will be pi square, pi r square over 2. That means let's write pi as a pi only. R is 40 square over 2. That means pi 40 times 40 into 2 by 2. So this will get 800 pi. Is it clear so far? That is the total semicircle area. Now from there we have to cut it down the smaller semicircle area. Okay, shall I show it to you? Let me show it to you. Just a second, because this is the only question which you need to understand. After that, all the questions are very simple. Can you see this semicircle? Is it visible to you?
Yes,
It's
ma'am.
proper, but it's kind of semicircle. Okay. Now here I'm going to cut it out, a smaller semicircle. Okay. Let me draw the smaller semicircle over here. Can you see this smaller semicircle I have drawn inside that? Can you see?
Yes, ma'am.
I'm going to cut it out. Okay, let me cut it out. From total semicircle area, I am just taking out the smaller semicircle area to show you what exactly we will be left with. From total area, I have cutted out the smaller semicircle. Can you see we got the track area?
Yes, ma'am.
Yes, Madiha, is it visible? Okay, is it clear now? From the bigger semicircle area, if you will take it out, that means if you will subtract the smaller semicircle area, you will be left with the area of the track, right?
Yes,
Yes,
ma'am.
ma'am.
Let's do it quickly. So now this is the bigger semicircle area. Bigger semicircles area. Now we are supposed to find the smaller semicircle area. That we will get again pi r square by 2. Here r is, for a smaller semicircle, r is 30, because for the smaller one the diameter is 60. So r is 30 over there. So pi 30 square over 2. Here we will be having pi times 30 over 2, which will give us 15 3 times 45, 450 pi. Now, as I said, as I have shown you, we have to do the subtraction. From the bigger one, we will take it out the smaller one and we will left with a ring kind of a structure. So, area of one of the semicircular track is equals to bigger area, that is 800 pi, minus a smaller area, that is 400 pi. Is it clear so far? So we will be having 400 pi as area meter square. Okay, of one of the track, like one of the semicircular track, but the same, exactly same two tracks we are having. So area of both the semicircular tracks, area of both semicircular track will be 2 into 400 pi, that is 800 pi. Now let's get back to our figure. What we were supposed to find? This one. We were supposed to find this one. So this one we have got 400 pi. This one also 400 pi. Area of rectangle is very simple, length into breadth. Here also area of rectangle formula, length into breadth. So once we will add all the area, we will be left with the area of the complete track. Is it clear? Yes, Jaslene and Madhya?
Yes, ma'am.
It's clear. Okay, let's move to the next question. So you are supposed to find the total area. Either take 400 pi 2 times, or you can directly take 800 pi 1 time. So I'm taking 400 pi. Then area of the rectangle is 106 meter into 10 was there. Yeah. Then again, one of the semicircle was there, 400 pi. And then again, area of the rectangle, 106 into 10. And that will give the total area. Here you are supposed to substitute the pi value. That is, let me check whether it is given in the question or by yourself you are supposed to take. No, it's not given. So we will be taking 22 by 7. Let's move to the next one. So the next figure, question number 9. So question number 9, we are having a circle like this. Here we have to find the area of the shaded region. Let me set the region first. Just a second. This one is the shaded region. And this one is the shaded region. What exactly the question says? O, C, D, B, A. Okay. Here the question says AB and CD are two diameter. As you can see, AB and CD both are diameter of a circle with center O perpendicular to each other. So both the diameter are perpendicular to each other. Okay. Here also it's 90 degree. Like both the diameter are perpendicular to each other. That's the given condition. Now, if OA is equals to 7 centimeter, find the area of the shaded region. We have to find the area of the shaded region. OA, let me see where is OA. This OA, that is 7 centimeter. So if this much is 7 centimeter, we can say this much is also 7 centimeter because it's the radius of the circle, right? This much is also 7 centimeter, this total.
Yes, ma'am.
Okay. And this total is also 7 centimeter. Now we are supposed to find the area of the shaded region. So this shaded region is very clear. It's a circle. And what is the radius of that circle? The diameter of that circle is teeny tiny circle's diameter is 7 centimeter. Yes or no?
Yes, ma'am.
Now radius of that circle will be 7/2. And easily we can find the area of that circle. Now what about area of this shaded part here? So here we will take the like total semicircle area minus triangle's area. If you will subtract from the semicircle, if you will subtract triangle area, then you will be left with the shaded part area, right? So
Yes.
what is, how we will find the semicircle's area? Semicircle area.
Triangle plus the shaded in the segment.
Yeah. So semicircle's area will be pi r square over 2. R of this semicircle, this B, A, C. This semicircle radius we already know that is 7 centimeter, right? So that will be pi times 7 square by 2. Minus we have to do the subtraction of triangle's area. So triangle area formula is 1/2 times base times height, right?
Yes, ma'am.
If you will focus on that triangle, we can say that AB is the base. AB is the base, which is 7 plus 7, 14 centimeter. Yes or no? AB is the base, which is equals to OA plus OB. OA is a radius 7, OB radius 7. So AB is 14 centimeter. Can you see from this figure? AB is equals to 14 centimeter. Yes or no?
Yes, ma'am.
So I am going to write 1/2. Our base is AB. Our height is OC. Is it clear? Because why I'm taking height as a OC? Because the condition is given as both the diameters are perpendicular to each other. So it is dropping like a perpendicular, like this one. So we can take that as a altitude, right? In our triangle.
Yes,
This
ma'am.
is 7, this is 7, altitude is 7. So let's write it 1/2. AB is 14 and OC is 7. We know all the data. We can easily find the area of this shaded part. Once we will get the area of this shaded part, we can go and combine it with teeny tiny circles area to get the total shaded region area. Is it clear?
Yes, ma'am.
Okay, let's move to the next one. Here we are having three circles like this, and like this. Okay, all are just all touching with each other. Here we are having A, here B, and here C. Okay, my figure is not that perfect, just like the book's figure. You have to check the figure properly in the book also. So here, let me give the overview what exactly it says. It says the area of equilateral triangle ABC is given. Area of equilateral triangle ABC is already given as 17320.5. Okay, centimeter square. With each vertex of a triangle as a center, a circle is drawn with radius equals to half the length of the side of a triangle. So radius of each and every circle is half the length of the side of the triangle. So if the total side length, like A is the side of the triangle, then this radius of each circle, this much radius, this much radius is A by 2. If A is the side of the circle, side of the equilateral triangle, that is the given condition, like which is mentioned in the question only. That if the side of triangle is 10 centimeter, then the radius of each circle is half of that, 5 centimeter, 5 centimeter, 5 centimeter. Okay. Now find the area of the shaded region. Here, this one is the shaded region. Okay, we just have to find the area of the shaded region. Now to find the area of the shaded region, can we say total area of the triangle minus this sector, just cut it down, this sector, just cross it, and this sector. So we will be left with the middle part, right? Yes or no? From the total triangle area, if you will exclude all the sector of the circle from the total triangle's area, if you will exclude this one, you will exclude this one, and if you will exclude this one, all the sector, then you will be left with this part only, no? Yes or no? Are you able to visualize?
Yes, ma'am.
Okay, so to equilateral triangle area, we already know that is 1730320.5. Now we have to find the sector's area, sector area of any one of the circle, and since all the circle are exactly same, we can multiply it with 3. How we will find the sector's area? Theta by 360 into pi r square. How we will do that? Okay, so here, since it's a equilateral triangle, we can say each and every interior angle must be 60 degree, right? So angle we know, theta we got to know 60 degree, but what about radius? Do we know the radius? So it says that radius is equals to half of the length of the side of a triangle. Do we know length of a side of a triangle? No. But area is given, then we can write the area of equilateral triangle formula. Root 3 by 4 side square is equals to 17320.5. From here, a square is equals to 17320.5 into 4 divided by root 3. Is it okay? Is it okay to you? Yes? Jasleen and Madhya. Is it
Yes,
clear
ma'am.
so far?
Yes, ma'am.
Okay. So here, this calculation will be If you will do the multiplication, let's do it quickly. It must look like very like a complicated calculation to you, but when you will do the multiplication, 5 4 times 20, 0, carry 2, 4 0 times 2. Now 4 2 times 8, 4 3 times 12, 2, carry 1, 29, 9, carry 2. This is what you will get. Okay, divided by root 3. 69282 divided by root 3 is there. Now if you will do is this is a square, right? So when it will go other side, yes, this calculation will take time. You have to let me check whether the value of root 3 is given in the question or not. Okay, so value of root 3 is also given in the question, that is 1.73205. And here we are having 69282. Now we have to think about whether it is possible to cancel them or not. Let me check it. When you will do the multiplication, 173,205. Suppose I am not taking the decimal for now. So if we will take 17 3 times 51, 17 4 times. So if we will do the multiplication with 4, it will be 5 4 times 20, 0, carry 2. 4 0 times 2, 4 2 times 8, 4 3 times 12, 2, carry 1, 4 7 times 28, 29, 9, carry 2, and 4 1 times 4 5 6. Can you see we got exactly the same thing? 692,820. We are having 69282. Can you see? Yes, can you see this calculation? Or without even putting the value, not to make you confused. Without even putting the value, let me show you. We don't have to do this. We don't have to do this. Okay. We just have to take a square is equals to 17320.5 into 4 divided by root 3 was there. Root 3 value is already given in the question, 1.73205. Okay. So can you see this? Both the numbers are exactly same. Only the difference of decimal is there.
Yes, ma'am.
Easily you can cancel them. Okay, just remove the decimal and easily you will be able to cancel them. So how many places are there? 1 2 3 4 5. Just a moment now. Just a moment. Okay, just do this calculation and do let me know what exactly are you getting. Okay. Yes, what you got? Jasleen and Madhya, what you got? Still doing? Can you see the screen?
Yes, ma'am.
So here, if we will multiply this one, like how to remove the decimal? Anyone? Anyone? So
Then we
here
can
only one place decimal, after decimal one digit is there. So we will multiply with 10 and decimal will get removed. Yes or no?
yes, ma'am.
And in denominator, how many digits are there? 1, 2, 3, 4, 5. 5 digits are there. So we have to multiply it with 1, 2, 3, 4, 5. Like this one. Okay. 1 lakh we have to do the multiplication, then only we will be able to remove the decimal. So in numerator, what is required? 10. In denominator, what is required to remove the decimal? 1 lakh. In between 10 and 1 lakh, which one is the bigger one? 1 lakh is the bigger one. So we will be taking that number so that both the decimal will get reduced. Okay, get removed from here. So we will be multiplying numerator and denominator by same number, that is 1 lakh. And this is allowed in mathematics, right? You can take a single number and you can do the multiplication of that in numerator and denominator of a fraction. So we are going to multiply 17320.5 into 4 divided by 1.73205. This with 1 with 5 zeros, 1, 2, 3, 4, 5. Here also we are supposed to multiply with 10, but we cannot do that. We cannot give 10 in the numerator and 1 lakh in the denominator. That is not allowed. Same number you can give. Okay. So 1, 2, 3, 4, 5. Once we have done the multiplication of the same number in both numerator and denominator, the numerator will absorb 1 0, but will be left with 4 zeros. So we will be having 173,205. Decimal gone with 1 0 and 4 extra zeros will be remaining. Is it clear? And in the denominator, all the 0 will get absorbed with the decimal. Now, can we say this will get cancelled out with this with 10,000? Yes or no?
Yes, ma'am.
Now we are left with 4,000 as a square. A value we can easily find out that square root of 4,000, that is 4 is 2 into 2. It's not 4,000, it's 40,000 because 4 zeros were there. And this 100 into 100. So 200 will be coming out. Is it okay?
Yes, ma'am.
This calculation was easy because the value of root 3 is already given. We just have to deal with the decimal, nothing else. No multiplication, no division. This all whatever we have done, this was not required at all. Okay. For finding the area of the shaded region, what we will be doing? Area of the equilateral triangle, that is already given in numbers 17320.5, and minus area of the sector of the circle. How we will find the sector of the circle? Theta by 360 into pi r square. Theta is 60 degree by 360 into pi. What is our r? R is half of the length of side. Side we have got as 200 centimeter. So r will be half of that, that is 100 centimeter. Is it okay?
Yes, ma'am.
And we are having 3 sectors. So whatever you will get area of one of the sector, you have to do the multiplication with 3 to take all the 3 sector in consideration, and that you will be taking it out or subtracting it from the total area of equilateral triangle. Is it clear to both of you?
Yes, ma'am.
Let's move to the next one. Just a moment. So the next question number 11, question number 12, question number 13, all are very simple question. Okay, a square is there, 10 designs are there, and you have to find the remaining area of the handkerchief. This one is very simple. You will be able to do by yourself. A brief overview of this one is here, here, here. 1, 2, 3. Yeah, a bigger square I have drawn. Yeah, a shape is there, square is there, and this and this. Here also this all are just touching each other. This type of design is there. This is design, something design is over. Okay, the circular one is the design one. we have to find the remaining area of the handkerchief. Here what is given? It's given that the circular design each of radius of each circle is 7 centimeter. So what we will do, total area of the square minus area of this design portion. Then we will be left with the remaining area. Remaining area means what? We will be left with these area. We just have to find the remaining area, the green one. Okay. And that we can do total area of the square minus the area of the all the circles. Do we know the side of the square? No, we don't know the side of the square, but we can find the side of a square by taking this as a 7, this as a 7, and this as a 7. So side of a square will be 7 plus 7 plus 7. Is it okay? Once we know the side of a square, easily we can find the area of the square. From the area of the square, if you will start cutting all the circle, if you will cut it down all the circle, then you will be left with this shaded region, the green region, which I am coloring right now. Can you see? Can you see it?
Yes, ma'am.
This is the area we have to find. You will be able to do, right? Now, after that, we are having the question as one question which I want to discuss here is this one, the last one, number 16. Meanwhile, I am leaving 2-3 questions for you. Please try it. If you can't, we will be discussing that in the next class. So the last question which I wanna discuss with you is here we are having this shape. Calculate the area of the design region. Here we are having the designs. Of this region. Okay. Now what exactly information is given over here? Common between two quadrant of a circle of radius. So this is a quadrant of a circle. Let me draw it separately so that you can visualize the shape. So this is the quadrant of a circle like this. And here also we are having the quadrant of a circle like this. Now you can imagine both. I will join. Then this will come this side. This will come that side. Getting it?
Yes, ma'am.
It is making this type of structure. We have to find the area of this structure. So here it's given 90 degree. It's a quadrant of a circle. And what else is given over here? Radius of each circle is given as 8 centimeter. Here also 8 centimeter. Okay. So if we will draw a line over here, if I will draw a line over here, can we see this is the segment of this circle? Can we say this is the segment? Like we get the segment like that only, right? This type of portion we have, and this two radiuses. Then this is how we get the segment. Yes or no? Just a moment. So this is how we get the segment. Yes or no? Yes, Jaslyn. Can you see it?
Yes, ma'am.
So here easily we will go and we will find the segment of the circle's area. That segment and this segment both will be exactly same, because in both the cases we are talking about the same semicircular, the quadrant, like 1/4 of the circle. Okay. So here you can